All right, let's dive in. Today we're looking at two really powerful tools in modern engineering, simulation and the digital twin. Now, they sound pretty similar, right? But they serve fundamentally different purposes. And, understanding that difference is absolutely key to seeing how our future is being built.
So let's kick things off with a huge question. Just imagine you're designing a massive skyscraper. How can you be totally sure it's going to stand up to the absolute worst case scenario? A hurricane or a big earthquake before you've even poured the foundation. I mean, you can't just build a practice skyscraper. The answer, of course, is in the digital world.
And that brings us right to our first concept, simulation. This is all about testing your ideas, testing designs in a completely controlled digital space, long before they ever become a physical thing. So what is a simulation, really? Well, at its core, it's basically a digital experiment. You build a computer model of something, a bridge, an engine, an entire building, and then you just throw all these theoretical problems at it to see how it performs. It's a predictive tool, and it's all about asking, what might happen if? The process itself is actually pretty straightforward. First, you build that detailed digital model. Second, you apply the theoretical conditions you want to test, like, say, hurricane-force winds or massive traffic loads. Third, you hit go and run the analysis. And fourth, you get these crucial insights that help you make the design way better. It's a completely self-contained static test. And here's where you see the real-world value. An engineer can simulate like decades of wear and tear on a bridge design in just a few hours. This lets them find all the weak spots and optimize the whole structure for safety and, longevity, all before a single piece of steel is even ordered. It's incredible. And this is the crucial part. Once that bridge is actually built, the simulation's job is kind of done. It's a snapshot of a design idea, right? It's not a reflection of the real living bridge that's now out there in the world. So how do you manage that asset once it's up and running? And that is exactly where our second concept comes into play, the digital twin. This isn't just some static model. It's a living, breathing digital copy of a physical object. So unlike a simulation, a digital twin is this dynamic model that is constantly connected to its physical counterpart. It isn't asking what if, it's telling you this is what's happening right now. It's less of a blueprint and much more of a mirror. So how does this magic mirror actually work? Well, it all relies on the Internet of Things, or IoT. You've got hundreds, maybe even thousands of sensors placed all over the physical asset, the bridge, the building, the factory floor. These sensors are constantly sending real-time data on everything from temperature to structural strain, beaming it right back to the digital model. This creates a perfect two-way flow of information. Okay, let's take a smart hospital, for example. Its digital twin is getting live data from every single part of the building. So, if an HVAC unit suddenly starts using a little more energy than it should, the twin flags it instantly. The maintenance team can then go fix the issue before it fails. This saves a ton of time, money, and it makes sure the hospital environment stays perfectly stable. That's predictive maintenance, not reactive. It's a game changer. Okay, so we've got these two really powerful concepts. To help it all click, let's use a simple but really effective analogy, thinking of it as a snapshot versus a live stream. This really just nails it. A simulation is like a photograph. It's a static image, a single moment captured under very specific controlled conditions. A digital twin, on the other hand, is a live video stream. It shows you exactly what's happening as it's happening, constantly updating to reflect reality. Let's just break down those key differences side by side. The whole purpose of a simulation is design and prediction. For a digital twin, it's all about management and optimization. A simulation runs on static, theoretical data, while a twin is all about that live, real-time data feed. And finally, a simulation is just that, a single snapshot in time. A digital twin is continuous, it's always evolving. So you might be thinking, okay, so it's one or the other. But the real magic happens when you realize they aren't competitors at all. They're actually partners.
See, this is not an either-or situation. Instead, what happens is these two technologies create this amazing cycle of design, operation, and improvement, where one is constantly feeding information back to the other.
So here's how that feedback loop works. You start with simulations to get the best possible design from the get-go. Then, once the asset is built, a digital twin takes over to monitor its real-world performance.
Now, the enormous amount of live data that twin collects gets fed back to create even more accurate, more realistic simulations for the next project. You see, each technology just keeps making the other one smarter.
What this all leads to is a whole new way of thinking about how we create and manage our world. Essentially, the future is built twice. First, in the digital world, and then in the physical one.
And the impact of this is just huge. By combining these tools, we get much better risk management, we lower costs over the entire life of a building, and we get vastly improved sustainability because we can optimize energy use in real time. This partnership, this is the true foundation of the smart cities and intelligent infrastructure we always hear about. So, I'll just leave you with this thought to chew on. If every bridge, every building, every single power grid in our cities had its own living digital twin, constantly learning and reporting back, what kind of massive problems, from traffic flow to energy consumption, could we predict and solve before they even happen? The possibilities are, well, they're truly staggering.